Um, yeah, I haven't looked at the project either.
The project's due Friday.
Yeah. Oh, yeah. I know. I'm. I'll probably get to it. Has anybody turned it in yet?
Um, yeah,
Oh, okay.
yeah, definitely. Yeah, I can bring it up because you can, it's not under grades. Let's see. Sure. Maybe not. No one person. Looks like nobody did. Everyone's waiting till Friday. Uh-oh. Okay. Well, did you have any questions on it?
Um,
I mean, I think it's something that can be done quickly, and that's probably why people are just waiting.
yeah.
Okay. Well, if you have questions, let me know on Friday.
Okay.
Well, there's
Uh,
two. Timothy, did you have any questions? Okay.
None that I can think of right now, but
Okay.
if I do, I'll email you.
Sounds good. You could look at the exam question about the white-tailed deer to kind of get an idea of how you would do it. I think I had it on both parts. I used like a small portion and had you explain on the in class, and then it was on the take home. How about the attendance? We didn't try it, huh? Do you want to work on the attendance or you want to work on new material? Since there's only two of you, I'll let you decide.
attendance.
Okay. They're not too bad, but let's look at it. A random variable S is defined based on the results of two independent coin tosses. And you get 100 or 100 if both lands heads, 25 if only one head, and lose 140 if there's none. So first, what's our sample space? We toss a coin twice. We could get a head on the first one and a head on the second one. We could get a head and then a tail. We can get a tail and a head or two tails. Now, to know if you have all of them, when you toss the first coin, there's two possibilities, heads or a tail. When you toss the second one, there's two possibilities. Multiplying those, there's 4 outcomes. So as long as they are independent events, meaning tossing the first coin can't change the outcome with the second coin, which it won't, you can just multiply the outcomes together to get the total. So there should be 4, 1, 2, 3, 4. No, they want it listed as, let's see, 2 independent coin tosses, both heads, only one head. So if we make a chart, I'm not making it big enough, I'm sure. We can have our outcomes. Both heads. One heads. So those are our possible outcomes. Now this could be value, it could be winnings. It doesn't really say, so I'm just going to call it a value. And probability. Now the book also did contributions next to it. If you want, you can, or you can just write it in your equation. This is contributions. Value. If both are heads, 100. One head. S is 25 if there's only one. And if it's neither, negative 140. Any questions on that? What is the probability that they're both heads? We have our sample space. Anyone? There's 1 out of the 4, so it's 1/4. Now you could write the decimal if you wanted. On cases where like 1/3, 0.33333, I'd keep 1/3. That way you're not rounding until the end. But this one doesn't, it's 0.25, so you could write the decimal. What's the probability that there's 1 heads? Anyone?
3/4.
3 or 2? We want only 1, so it would be these 2 out of the 4. Do you see why it's only 2?
So those two are technically the same, so you only count one of them.
No, we're counting both of these. Because the head could be on the first toss or the second toss, but it can only have one of them. This one has 2 heads, this one has 2 tails, so it's just the 2 out of the 4. And then the probability of neither one of them being heads, that's only this last case, which is 1/4. Notice if we add the probabilities up, 1/4, 2/4, and 1/4 is 4/4, which is 1. Probability should always add up to 1. Now, there was a couple problems where you rolled 1 die and you got something. Then you rolled 2 dies for the next one. That will not add up to 1. But when you're using your entire sample space, it should add up to 1. Contributions, just multiply across. 100 times 1/4 is 25. Multiplying across 12.5 and a -35. Any questions on that? No, I'm gonna, oh, I might have enough room to put here. And they called it S, so the expected value of S, you add your contributions up. So this game is a winning game. It's, if this was dollar amounts, then over many times of playing it, you'd average $2.50 per play. So in the long run, you will win, unless you're unlucky and you get no heads several times in a row. But it's expected over many times that you'll win $2.50 per game. If this is in dollars, it doesn't state. But is there any questions on finding the expected value? So you want to set, I think tables are the easiest way of setting them up. If you didn't put the column for contributions, you could just take 100 times 1/4 plus 25 times 2/4 plus a -140 times 1/4. And you'll get the same thing. Any questions on that one? Try the next one. A gambling game works as follows. You pay $5 to play. Then a die is rolled and a coin is tossed. If the coin lands on heads, your payoff is the number of dollars rolled on the die from 1 to 6. So if you get a heads, then you roll a 1, you get $1 back. If you roll a 2, you get 2 back, and so on. If the coin lands tails, you get double. So if it lands on a 1, you'd get 2. If it landed on a 6, you'd get $12. Well, let's think of the sample space. Find the number of outcomes. That way we know we have them all. We roll a die and we toss a coin. So when we roll the die, 6 sides on a die and 2 on the coin, we should have 12 outcomes. Heads with a 1, heads 2, and so on, all the way to 6. Those are all the cases if we toss a heads. And then there's the tails with all of them. 1, tail 2, tail 3, tail 4, tail 5, tail 6. No, it didn't ask you to list them all, but it definitely helps you find the probabilities if you list them all. And there should be 12 of them. Any questions so far? I'm going to call the value winnings. We probably need to list them all because each one has a different winning. Where this one, we only put one heads, we didn't write them separately. We were able to put them together, but here you're winning different amounts depending on the number on the die. So you have to list them all. One, two, three, 4, 5, and 6. Sometimes the book puts the outcomes going across. I like to work down because then I just add down and multiply across. That would be all of my outcomes. There should be 12, 6, and 6. Now we have to think about our winnings. Now, when you're talking about your winnings, you have to include the $5 to play. This one didn't have anything that you had to put down to start with, but this one does. So if we toss a head, remember heads, you win what's on the die. So if we have this one, we're going to get $1, but it costs 5 to play. So 1 minus 5, we're losing $4. Because you want to subtract this 5 here every time. So if we get heads with a 2, we get $2, but it costs 5 to play. We're out $3. Any questions so far? Okay, so then it would continue. Heads 3 would be a -2. 4 would be a -1. Now here, we're paying 5 and we're getting 5. So we're at 0. At least we broke even. We didn't lose any money, didn't win anything, but we didn't lose. So all these first 4, we lose money on. This one, we break even. And this one, 6 minus 5, we win $1. Any questions so far? The tails, you win double. So a 1 wins you 2. 2 minus the 5 to play, we're still lost money, but here's 2, so double is 4. You only lose $1 there. 3 doubled is 6. We win $1 here. Any questions on that? Four doubled is 8. 5 doubled is 10. 6 doubled is 12. So getting a tails, we have better probabilities of winning than heads. Any questions on that part? So you take your winnings and subtract what it costs to play. For the final project, you're going to create a game, kind of like this is a game. It can be a spinner, it can be tossing coins or heads or a mixture of them, however you want to do it. And so you'll have to have the amount to play and different types of winning. Any questions? Not how. what would the probability be for the first one? If you get a heads and a 1, what's the probability?
1/6.
Almost. Remember our outcomes, there's 12 of them. So 1/12. There's one that's a heads and a 1 out of the 12. How about the probability for a heads and a 2? How many are there? There's only one out of the 12.
1/12.
Yeah. How about a heads and a 3?
Is it the same thing all the way down?
Exactly, because we listed all of them since each one had a different winning amount. They're all 1/12. Now we could have combined, no, none of them are the same. Yeah, we could, like if one of them had the same winnings, we could have combined it, but you didn't need to. And so since we listed every sample space, these are all 1/12. On this one, these two were 1/4. This one, we combined a head and a tail and a tail and a head. And that's why it was 2/4, because there was 2 of them. This one, we wrote each separately, so they're all the same probability, 1/12. Contributions, just multiply across. I wouldn't reduce them. The reason I wouldn't reduce them is because you could just add the numerators and then divide by 12. Because they have the same denominator. You can take -4 -3 -2 -1 +1 -3 -1 +1 3 5 7, and then get that answer and divide by 12 because they're all the same denominator. Another thing we could do, here's a positive 1/12 and a negative 1/12. Those cancel. Is it the only, oh, 3 and a 3? -3 and +3. So you could cancel some of them also. I'm going to add all of them. -4, -3, -2, -1, +1, -3, -1, +1, +3, +5, +7. 4 3 2 1 0 1. You're getting 3/12. Yeah. Any questions on that? So what this is saying, it's a positive. Now I rewrote the 0.25 to change because there was no whole dollar. If you play this game several times, you'll average a winnings of 25 cents per game. So if it's fun to play and you want to sit there and play for a while, you're not going to lose money in the long run. You're going to gain 25 cents a game. However, if you're unlucky and you keep tossing heads, you could lose a lot before you start winning. Any questions on that? So it's up to you. Make sure you do explain, would you play this game? It's up to you, but this is saying if you play it several times, you win 25 cents per game. Now, if you played it 100 times, to find out the amount, you would take 100 times the expected value. So if you play it 100 times, you should win about $25. Now that's just a probability. Probability is by chance. Any questions?
So you have to pay
Yeah, it was
$500,
$5.
$500 to win $25.
Yeah. Well, no. It's saying if you played and spent $500, you would be ahead 25. So you'd still have your 500.
Oh, okay,
Because
okay.
we included that in here. We subtracted the 5 out. So if you play it 100 times, you'll be ahead $25. So you'd have the 500 plus that.
Okay.
Yeah. As long as your chances are pretty equal. Any questions on that? So make sure you write a couple sentences about whether you would play or not. I think $5 is kind of high because if I lose the first few times, I'm out a lot of money. In the long run, it's going to even out, but how much you have to keep playing and losing before it starts evening out. Now, if it's only $1, then you start catching up faster. So that's another thing to look at. If you lose the first 3 times and get the -4 or 0, 0 is good because you broke even. You didn't spend your 500 because you got it. I mean, your $5 because you got it back. But if you lose too many times, for me, it's a lot. Any questions? But it's all your opinion. The Student Sustainability Circle plans to host an outdoor fundraiser. The tickets for the event are $1.60 each. If the weather is not rainy, then 500 people will show up. And buy tickets. That means if it's not raining, 500 people will buy tickets at $1.60 each. If the weather is rainy, 80 people will show up and buy tickets. On the day of the fundraiser, there's 28% chance of rain. We need to find the expected value. Let's see. So our outcome is it either rains or it doesn't rain. And then we want how much money we'll make. Because it's a fundraiser. What should we call it? Fundraiser? We'll just say it. So we need to figure out how much money we will make. If it rains, how would we find out how much money we'd make?
Multiply the $1.60 times however many people show up, the 80 people.
Right, so if it's raining, 80 people show up, so 80 times 160 or $1.60, we'd make $128. How much will we make if there's no rain? Anyone? If there's no rain, 500 are going to show up. Then they're going to pay $1.60 each. You're getting $800. Any questions on that part? What's the probability of rain?
One half.
Right here.
Oh,
Yeah, instead of being 50-50 chance, they actually gave us the weather forecast, so 28%. Now remember to write it as a decimal because we're going to multiply across. If it's a 28% chance of rain, what's the probability of no rain?
$72.
What we did was we used the complement. 1 minus the probability of rain was 0.28, 0.72. Any questions? Contribution, just multiply across, so 128 times 0.28. And 800 times 0.72. Now on this one, they want the expected value of the tickets. They don't want it combined because it's only a one-time thing. It's not something, unless they're doing it every month or something like that. So they want the probability of the tickets given rain. Or not probability, should be expected value. And the expected value of the tickets given no rain. So they probably wouldn't put it together because we're not finding out over time. If we wanted to say they do this every year and they want to find out approximately how much they'd make per year, then you could add them together. And I probably should have put on this one expected value given it rains and it doesn't rain. Remember that line means given. So the expected ticket sales given rain is the 35 because that's the rain. 35.84. The expected ticket sales if there's no rain, 576. But you could add them. I would not take off if they were added together. So either way. Any questions? This one, I printed it out on my sheet, but the problem is on page 340 and it's number 46. I want to travel from my hometown to San Francisco. 3 air carriers compete for my business. Epsilon Airways, Jet Green, and Unite. Oh, Untied. I was thinking it was, okay, yeah, Untied Airways. On the way, one or more of the following events may happen which will increase or decrease my satisfaction with the journey. Flight canceled, -15. Baggage lost, -5. Cramped seat, -2. Free upgrade, that would be nice, a +4. So those are units of satisfaction. From experience, I know the probabilities of these events on the different airlines are these. Which airline should I take? Well, we know satisfaction canceled, -15. 15. Baggage lost, -5. Cramped seating, -2. And a free upgrade of +1. So those are their units or their values. And this is the probability, and you do each plane separate. So for epsilon, we do -15 times 0.1 plus a -5 times this one, plus -2 times this one, and 4 times this. Add them up, and that's the expected value of it. It's up to you. There's enough space here. You could actually multiply here and then just have to add them up. -15 times 0.1. -1.5. So that would be the contribution. -5 times 0.05, -1/4. And then you add them up. -1.5 minus the 1/4 minus 0.2 plus the 0.8. So this one is unsatisfactory because it's negative. Is there any questions on that? And then we do the same thing for the next one. 15 times 0.08. Notice this one getting an upgrade, there's no chance with jet green. They're not going to give an upgrade.
Your satisfaction for this flight isn't looking so good.
No, it's not, is it? I'm definitely not taking this one. You're getting a -2. Or 8, 10, yeah, -2. How about United? None of them are great. What are you getting for untied? So none of them are positive. But this one is the lowest. So untied is probably the best one. And notice you're not going to lose your baggage. That's a good thing. And highly unlikely that it's canceled. Any questions on that? So this tells you your satisfaction. You're not going to be happy with any of them, but this one has the lowest possibility of being unsatisfied. So to maximize your expected satisfaction, you want to do untied. And maybe you'll get an upgrade and it'll be good. Any questions on that? So remember to answer the question, which airline should I choose? After looking at your expected values. Any questions on it? Okay. If you do not have any questions, I will see you on Friday. Thanks for coming and have a nice day.